So for example, in one language you might have a syntax that looks like this. So, declare an integer named x. Declare an integer named y. Set x equal to 3. Set y equal to the value of x plus 3. We might get some input. You know, we're going to declare a variable named z. We're going to get some input into z. And then we're going to say z is equal to y times 2. And then we're going to write that back. Whoops, I made that the wrong word, but it does not matter because this is just an example. And then we're going to write that back out to the screen so that somebody can see it. Okay, that's kind of what the C++ language looks like. A very, very short example of it. Python is going to do something, it needs to do all the same commands. Let's throw in something else in here. We're going to do if z is equal to 5, then we're going to write out the value of z. Or no, if we're doing a program to see if something is less than freezing, right? So if z is less than 32, we're going to do one thing, else we're going to do something else. We'll write out another number. And the cout stands for console output. Whenever you're talking about a console, that's that window that commands can execute in. All right, so that's one program. Here's what it might look like written in another language, such as Python. X equals 3. Our font is too tiny. Y equals x plus 3. Z is equal to input. And then this is dumb. Once we store something in Z, we just go ahead and override it. And then we're going to have an if statement. If Z is less than 32, we're going to write something out. We're going to print the value of Z. Else, we're going to print the value of Y. All right, there's the same program. In some languages, you have to declare your variables ahead of time. Meaning, I'm going to create a variable called x, and I'm going to declare it to be of the integer data type. Int meaning numeric whole numbers. In Python, you don't have to declare them ahead of time. You just say, okay, I want something called x, and I'm going to stick a number in it. And the variable type gets dictated by what we're copying into it. And then later on, if we want to store something else in it, then it kind of remorphs the variable to hold something else. In these languages, you can't do that. Once you declare x as an integer, it's going to be an integer the whole way through. You can't suddenly go and store a word in it. And so here we declare two variables, and then we stick a piece of data in one. So these two statements here don't even have any equivalent over here, right? We don't see those at all. But we do see x is equal to 3. We do see y is equal to x plus 3. We see another difference in that the C-based languages and all of its children, like Java and stuff like that, need a semicolon after most of the statements. Here we don't have semicolons after most of the statements. We don't have semicolons anywhere. The math looks the same, right? Getting input looks dramatically different, but getting input in any programming language looks different than it does in another one. So that's to be expected. Like I said, once you learn one, you're well on the way towards learning another one, but there's always differences. And there's another mathematical algebraic calculation, and here's an if statement. Notice a big difference here is that in these languages, blocks of code are dictated by the curly braces. Here, in our pet language, blocks of code are dictated by tabbing. We don't have curly braces in it. Another thing to notice is that every time you're going to start tabbing, you have to have a colon in front of it. You don't have to have a colon in this language. In this language, the curly braces are optional. If the block of code is only one line long, you don't have to use curly braces. So since these blocks of code are only one line long, right, we can leave those out. Those languages say that's fine. Python doesn't use the curly braces, but it still says that anytime you start tabbing, there better be a colon and a line above it. You don't have to memorize that right this second, but like within a day or two, you're gonna already have that fixed in your brain. All right. I think that's about enough of that. I could give you examples in other programming languages, but that'd be belaboring the point. I'm going to copy this and paste it into my other notes over here. And I do upload these notes at the end of the class. So if you find it useful to type in notes, that's great. But if you can't type as fast as I, which is possible, then you will find them in the notes section of contents in our D2L. Okay, so this is a program loosely written in C++. This is a program written in Python. Even the way you give comments to the program is different. In this language, you use double slashes, and anything after the double slash says this is a comment, please ignore it. In our language, you use the hash symbol, the pound sign, the number sign, in order to say this line you ignore, Mr. Computer. I'm just putting it here for me to remember later. Now, you know, why did the programmer of that not use // just like his, you know, the forebears like that? Well, he made // do something entirely different, which is the programming language inventor's prerogative. And we'll talk about what // does in our programming language later. So the syntax, those are the rules that govern. Let's see if we can zoom this in here. The word usage and the punctuation. We have to get the syntax right. Now sometimes there's multiple ways to express syntax, but the syntax still has to be right. And I'll give you an example of when I just said multiple ways of expressing syntax. If you're going to take a number like x and you're going to add 1 to it in this language, you could do that to it. That says take x, add 1 to it, and store it back into x. So if x was 10, after that's done is 11. In our programming language, you can also write it like this. Take the value of x, add 1 to it to get 11 or whatever, and store it back into x. Those do the exact same thing. Why there are two different ways of doing it? Well, because maybe we're not adding 1 to x, right? Maybe we're adding 1 to y, and then storing the result back to x. If we have this statement, it's not actually changing the value of y. It's just like when you were doing algebra or something like that, right? You had to just calculate everything on one side, and then that got put, you know, across the equal sign on the x. And so after this is done, y was still whatever it was, right? So if y was 10, then x becomes 11, but y stays 10. So this is two different syntaxes for expressing the same thing. In C++, as I mentioned, there's even other ways. There's the ++ symbol, and then there's the other one where the ++ comes first, and each one means subtly different. Well, we only have two ways. But again, we have multiple ways of doing it. That's not true for everything. Quite often, there's only one syntax. I'll give you another example. The if statement. Say we want to see if the temperature is less than 0 or less than 32. If temperature is less than 32, then do something. Notice the colon. You can also express it like this. If temperature is less than 32, you can put parentheses around it. You can put parentheses in lots of places. If you wanted to do that, great. Now we're getting silly. If you wanted to do that, great. You know, when you're writing an algebraic expression, you know, the parentheses mean something, right? It means the first thing you do in the equation before you do anything else. But if you just put it around a number like that, then there's nothing to do to it. But anyways, here's two different syntaxes for accomplishing the same thing. I will occasionally type that because that's how the C++ and the C and the Java languages do it, like I showed over here. Here was an if statement, and it had the parentheses. Here's the if statement, and it doesn't. Our language doesn't care. I will try to type them without the parentheses because that's the more standard way. That's the way that you would see code examples out on the internet and stuff like that. But that works just as well. However, syntax is awfully important. You can't do this if, I'm trying to come up with a false one, if temperature is less than 32. Now, unfortunately, when I'm reading code and hoping y'all are typing along, I'll throw the word is in occasionally, right? If temperature is less than 32, you heard the is, but you don't type the is. That's kind of my mistake. for saying the word is, but that's, the English flow of it. I should just say if temp less than 32, right? But that sounds kind of robotic. When I'm talking about it, likely I'm going to say if temperature is less than 32. I will try to do that a majority of the time so that I don't wander around and everybody's got syntax errors. This would blow up, and what I mean by that is that it would not run. If that line of code was in the program, then when we tried to run it, we get some red text and an error message, and the program would not run. So that one's bad because that is word. This is the syntax, just like English, versus German. They have different syntaxes. Fairly close. English is kind of based on German, not really, only partially. But, I think I gave the example of French versus English, where the adjectives follow the nouns in French, but they precede the nouns, right? We have a red tractor as opposed to a tractor red. And if you use the wrong one, then somebody will stare at you and wonder what you're talking about. But humans are smart enough to be able to kind of figure that out, right? If I walked up to you and I said, go look for the tractor red, you'd be able to figure it out, but computers are more literal. Mistakes in that language are known as syntax errors. These are important enough that I'm just going to copy and paste them into my notes. Or I should type them for the people who are typing along to get a chance. But anyways, so what is syntax? Syntax are the rules in grammar. And then syntax errors. Mistakes in the rules. And not only in the rules, but if you misspell something. Like if this was a capital X right there, and actually maybe a capital X. It's hard to tell the difference, right? But if that was a capital X and this is a lowercase x, then when it's running along, it's going to complain. It's going to generate a red error and not run. The reason why is that this, in the vast majority of languages, are case sensitive. Meaning that if I write this, x, or if x less than 3, as opposed to if x less than 3, this is the only one that's correct because it's got the lowercase I. So it's not like English where you start each line with a capital letter. We can pretty much say we're hardly ever going to use capital letters. That's not strictly true. But in general, the capital letters only get used, well, I won't even talk about it. Sometimes I will use capital letters just to make things easier to read. Like if I'm going to type a lowercase l, and I call it L3, that looks a lot like maybe it's I3 or 13, right? So I might make it a capital L just to make it really clear what it is. Similar, a lowercase o and an uppercase 0 are easy to distinguish. Uppercase O's and uppercase zeros are difficult to distinguish, so I'm never going to make a variable name that differs just based on an O being treated as something different than a 0. We will learn the rules that we will probably follow, our guidelines, well, there are rules and there are guidelines for how we capitalize and how we don't, and what things you can give to variable names. Like you can use numbers in your variable names if you want to. You could say A1 is equal to 3, A2 is equal to 4. That is acceptable. But saying 1A is equal to 3 and 1B is not. Again, I'm not expecting you to remember this in just that exact second. Maybe you will. We will mention that in more detail. But it's important. The syntax of the language says that you cannot start a variable with a number. It has to start with a letter. And then once that letter is there, then it's fair game. You can mix all the numbers and the letters that you want. You could call it Z, one or right, That's a stupid variable name, right? But it's totally legal. But if we took out the Z, that would make a variable name. That was not. So the computer memory, RAM, that's the stuff that's lost when the power's off. Your phone gets kind of stuck, so you hold the button until your phone reboots, right? And then all the RAM gets lost, right? It gets all reset to 0, so hopefully your phone will start working again. That's volatile. not meaning it's going to explode when it gets upset, but volatile meaning that if it loses its power, it loses, its state. And I think that all computers ought to have, some kind of built-in, I don't know, you engineering guys could probably tell me how to do this, but it ought to be able to go at least like 2 seconds without power, right? In my mind, so that if the power flickers, we get a temporary, half a second blackout, the lights flash like that. I'd like it if the computer kept running, if there was enough capacitance built into the system that it would keep running. And of course you can buy boxes that do that, right? The UPSs, the uninterruptible power supplies, that can run, 30 minutes if they're unplugged or whatever. When I used to work in an office that had a mixture of Macs and PCs, at that time the Macs had enough capacitance, enough in their transformer or whatever, to run for a couple of seconds after the power went out. And so when the power went black and then the power came back on in an instant, all the PC users would go, ah, and the Mac users would not have lost their data. However, that was a long, long time ago, and I don't know if Macs are the same way. But we're all pretty much familiar with the idea that once the power flickers, it's gone. And then you have what's known as permanent memory. Now, is it really permanent? If if you go on the Planet of the Apes and Charlton Heston's looking at the Statue of Liberty and he finds a hard drive, is it likely to have all that information? No. But the idea is it's non-volatile. You're supposed to be able to turn it off, and it keeps it. So every device, all of our phones and all of our computers and whatever have 2 kinds of memory in them. Our PCs used to save everything to disk, right? You always had spinning magnetic media or whatever. Before that they had even weirder versions of it. Well, nowadays people buy solid state disks because they want their laptops to run faster and stuff like that. And there's obviously no disk drive inside our iPads and our iPhones and stuff like that. Disks kind of went out the window. The iPods for a while had the spinning little disk in them, and then the later versions did not, and people stopped using disks in their handheld devices. The point of that is that it's non-volatile memory. That's where all your applications get written, everything that's supposed to be saved between when you turn it off, right? Your music, your contact lists, right? You're writing something into a little tiny word processing program on your phone or whatever. You're taking notes, you're making voice memos and stuff like that. All of that has to be saved to the non-volatile memory. And that's a different kind of memory than the RAM. So when you buy a phone, there's 2 different kinds, right? You'll see that, okay, my Samsung has 64 gigabytes. I don't remember. Yeah, probably, 16 gigabytes, whatever, of storage. And then they have 1 gigabyte or 2 gigabytes of RAM because they don't need to load the entire hard drive in a memory. Just like if you have a PC with a great big 1 or 2 terabyte, that means trillion bytes. But when you bought your PC, it only had a certain number of gigabytes, which is 1 billion bytes. And there's no way you could fit 1 trillion into 1 billion into its RAM, right? So you don't load the entire contents. It only has to load enough in order to run. That's why your phones and your PCs and stuff are like that, are allowed to run under far less memory than what's written out to disk. So when you type in some code, it gets loaded into the computer memory. If I come over here and I pop up idle, I need to come up with some program for y'all to type along with me so we have something to upload, but I'm not coming up with it yet because this is a general lecture. Anyways, I type in a program here, file, new, don't know what I'm going to make it do, right? X equals 3. That's enough, right? That's a program. Then when I save it, it gets written out to the hard drive. It gets put out into so-called permanent storage. So when I save it, whatever, I'm just going to call it dummy.py because it doesn't mean anything. So it's written out there, but it's still not, it doesn't do anything, right? If I make it print 3, right, or print X, it doesn't do anything. It didn't print X, it just sits there waiting for something to happen. So when I run it, then the magic occurs. This needs to get turned into the opcodes that control the chip, right? So this English-like stuff has to be turned into opcodes that control the chip and make the computer do stuff. And the opcodes, like you saw, are just numbers. Everything underneath the computer is all numbers, right? And so this stuff had to be turned into the machine language that the computer would understand. And machine language differs on a platform-by-platform basis, which is why you can't store your iPhone apps on your Android phone and run your Linux apps on your PCs and stuff like that, at least not without going to some trouble. It's up to the compiler or the interpreter to turn that that text into machine language for the computer to run. What's the difference? A compiler takes the source code, converts it to machine language, and writes that out to disk. So, you get an executable out of that, right? You take your file, your source, it goes through the compiler, and the output is a .exe file that you can run. Or different platforms call them different things, right? The Mac calls them .apps or something like that, and you always talk about applications on your phone and stuff like that. I keep gesturing towards that. I need to put a phone out so that every time I gesture towards it, it really is a phone. How about that? Okay, so that's what's going on. Is the compiler is making machine language that then gets stored into an executable. The executable is what you give somebody else to run. Then you can give the .exe to someone else to run it. You don't have to give them the source code, right? You don't have the source code for Call of Duty or Office or anything like that. An interpreter works differently. You take your source code, it goes into an interpreter line by line on the fly, turning it into machine language, which gets run right then and there. I'm going to separate this into two steps. Up here, once you have an executable, the executable is then run, right? This looks like a shorter process in a way, right? It only goes through several steps. It goes to the interpreter, it's machine language, it runs right on the spot. That's how Python works. That's how JavaScript works. When we run the program, it doesn't get turned into an executable, which somebody then later runs. Instead, it runs on the fly, right? If I pop open that idle and I run it again, then it's going to run instantaneously. That means that when you take an interpreted language, like Python, you have to give them the source code in order for them to run. Now there's some nebulous range where you could argue that that's not strictly true, but that's fundamentally the idea. The same is true of JavaScript. JavaScript is the stuff that makes our web pages interactive. And so if I view a web page and I right click and I do view page source, there's a whole bunch of JavaScript in there, right? That controls Google's search results. Now, to me, that looks a little bit ridiculous because it's an insanely simple web page, right? Well, I guess not once we've done a search. But if you have a simple web page, this is the simplest one I know. All right, it's just a picture of an anime character named Lum. And, it looks like there's something broken up here, and it's got a background, and it's got a planet off to the side. So if we view this page source, there's not any JavaScript in it. But that JavaScript had to be sent to our computer on the fly at the same time the web page was loaded. So when Google's web page was being loaded, all that code was sent with it to be interpreted. So let's talk about the advantages and the disadvantages of each. Compiled language. Since it is turned into machine language once, it runs lickety-split, right? It can make an executable that's finely tailored, right? It's very precise and very sped up for your platform, which is great. You want your games on your Xbox to run as absolutely fast as possible, right? So, the machine language runs as fast as possible. the interpreter, but the disadvantage is that you don't get the source code. Let me break these out. Meaning you can't improve it. Now, there are open software people who like writing programs that they then upload to the internet so that anybody can change them. And then that's not so true, right? But usually people don't give you their source code. So an interpreted language, the disadvantage, right, you just flip those, if I could type, is the program doesn't run as fast because it's got to turn it into machine language on the fly each and every time it runs. It cannot be optimized. It has to read in a line of code. It has to turn it into machine language right then and there. So the disadvantage is it does not run nearly as fast. You would not write your favorite shoot-'em-up program in an interpreted language. Now, for simpler programs, people used to, I don't know if anybody plays face games anymore, Facebook games. I used to get all these notifications like Mafia Wars, people are trying to get me to do this, or Farmville, Those were probably written in some kind of interpreted language in order to, be as widely distributed as possible so that you could play that thing on your phone or whatever. But it would not be a really fast program, right? The rigors of a Scrabble program are not anywhere near the rigors of a first-person shooter. Okay, and then the advantage is you get the source code so you can improve it. Python is an interpreted language. That's why we're able to do this stuff so easily. We can type the code in, press the button, and it instantly runs. We don't have to type in the source code, run a compiler, it generates some object files, and then we have to link the object files together, and then we can run the execute, right? It requires all these steps to take C or C++ code and turn it into an executable that can run. Then there are languages that blend the two features, but we're not going to talk about those. We're boiling this down to the hardcore basics, the ultimate definitions. So when we type in our programs and we run them, we enter source code, we press the run button, which saves it, right? Save the disk. When you type a K and when you type a C, all right. Saves it to disk and then interprets it line by line, which is called running it. Interpreting it line by line and letting the computer run the machine language, right? Before it runs, before it starts interpreting it, Python does a sanity check. It scans through it, checking the syntax. Because if it starts interpreting it, and then it finds, 100 lines later that you capitalized an if, right, when you weren't supposed to, and your program crashes then, you could be much unhappier than if you ran it right and it worked. You want your stuff to fail as soon as possible. That sounds silly, but you want to know right from the get-go that something is not going to work. Those are bugs that are easy to fix. Those are errors that are easy to fix. And so when we run it, we're going to call it compiling. But it's not really compiling. It's a sanity check in this case. Check for syntax errors. Just note that I put quotes around it because it's not really compiling it, right? It's not making it executable. And then it starts running it line by line. And it keeps running it until the program stops or it hits an error from which it cannot recover. And so it might be a program that'll keep repeating over and over and over. Or it might be a program that just runs and stops. If it's repeating over and over, it's because there's a loop in it. Did I do loops last time? Did we write counting programs that would count, from 1 to 100 and stuff like that? Well, let's do that. So I'm going to launch idle. I've already got it launched, but y'all don't. IDLE. And please never type in your programs into the arrow prompt. Instead, you can type stuff in there, but then if you make a mistake, then you can't fix it. Like if I do this, A is equal to input, what? And then I realized that I was supposed to, make it an H, W-H-A-T. There's no way to go back up here and fix that. It's just not going to work. It's not even letting me edit it. So, File, New File. Let's ask the user for what they want to count up to. Print. How old are you? And we're going to say happy birthday once for every year. That'd be really annoying if you went to a restaurant and they said happy birthday 32 times because you were 32 years old, but let's just roll with it. So print, parentheses, quote, how old are you, question mark, and then end quote, end parentheses. And after a certain amount of time, I expect you to know that after our message, there's going to be an end quote, and after that, there's going to be a parentheses. Every opening quote has to have a closing quote. Every opening parentheses have to have a closing parentheses. So if I say the text, print, how old are you, when I'm reading this stuff out, at a certain point, I'm going to want you to know that what I mean is print, parentheses, quote, how old are you, right? I don't want to have to say all of that. And when you're in a work environment and somebody's talking about the way the program works, they're not going to say print, parentheses, quote. They're just going to say print, how old are you? All right, so we have a message, and now we're going to get that data from the user. Age equals input, parentheses, in parentheses. All right, next. This gets a string from the user. I'm going to type this as a comment. Gets a string, a string from the user. What does that mean? A string can be anything. It can be somebody's name, it can be 20 question marks in a row, it can be a number. Hopefully it's a number, but we don't know that. But that's what we get. It's the same for a web form, right? You're filling out a web form and it wants to know your address and zip code and stuff like that. You're typing on a keyboard, so it's generating strings. Later on, that data may be turned into something else, right? Your birth date, well, nowadays the phones or whatever let you have those little spinny things, that you choose your birth date instead of typing it in. But anyways, we have a string. We can't do math on a string. I'm going to even put that as a comment. We can't do math on a string, so convert it to a numeric form, which I'm going to shorten as number. Now, broadly speaking, there are two numeric forms. There are ints and floats, integers and floating point numbers. And you know that an int is a whole number. Now, that's all we really need at this point, right? Because we're not going to ask them and sing happy birthday 3.5 times, right? We're going to sing it either 3 or 4. So we're going to convert our string to an int. Let's use an int. So what we're going to do is say convert the string to an int. And by the way, when I'm typing all these comments, you can skip them, right? Because I just said a little while ago that comments are stuff that are ignored by the computer, right? It's like writing parenthetical notes in the margins of a book. It doesn't change the book. On the other hand, it explains what it's doing. So if you can keep up and you feel like typing the comments, great. Okay, now we're going to convert age into an int. Age equals, and you don't have to put the spaces that I do either. I put them to make it clear for y'all to read. Is this font big enough for y'all in the back row? Okay. If it ever becomes not so. All right. So age equals, excuse me, int parentheses age. And you just heard me do it again. I said int parentheses age. I did not say closing parentheses. I mean to at this stage. At a certain point, I'm not going to be giving out all of that, verbiage, because it makes it longer. All right, now we have an age. Now we're going to write a so-called loop. The loop is going to make it say happy birthday that many times. Now the loop follows a very specific syntax. For, and I think I'm just going to use X. I could call it anything. I could say for counter, for year, whatever. For X in range, in space range, parentheses, 1, comma, or now let's just do 0, comma, age. And at some point I'll explain why I did that. So 0, comma, age, comma, 1. End parentheses, colon. Now that may look complicated, but all it means is start counting at 0 and then go up to, but not including age. Why? Not including? Well, if we're going to count 4 different times, and computers generally start counting from 0, and as a matter of fact, if I left that 0, comma off, it still would start counting at 0. I want to count 4 times. 0, 1, 2, 3. Now that's really my 4th finger, right? But I wanted it to count from 0 to 3. 0, 1, 2, 3, which made 4 numbers for us to print out. So we took our age, and it's going to go up to, but not including age. So if they type in 4, we're going to go 0, 1, 2, 3. Now other languages do their loops a little bit differently. We just have to remember that this is not the number at which it stops. It's one past the number at which it stops. And that's kind of weird, but you get used to it. Okay, now since I have a colon, it automatically indented. That's good. Every time there's a colon, the indentation is supposed to start. And if you backspace, it's not going to work. Okay, so we're going to do print. You know what, we're going to delete that for statement. I'm sorry to switch gears on y'all, but the for statement syntax is a little more cryptic than what I'm about to do now. X equals 1. If anybody has an iPhone and can tell me why it does that ding, 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 ding when I get a text message, that'd be great, because I did not change the sound. All right, anyways, while X is less than equal age, colon, print, parentheses, quote, happy birthday, exclamation mark. Guess it's an exclamation point. End quote, end parentheses. And by the way, if you don't like these colors, or if yours for some reason is showing purple, or red, and you like it purple, you can configure that by going to configure idle. And you can find a place called highlighting. And I really don't like the color orange, and so I'm going to make the color orange be brown or something to be easier to read. But I didn't make that change. And then X plus equals 1. Now when it's done saying happy birthday, happy birthday, happy birthday, we're going to print and many more. Print, parentheses, quote, and many more. Dot, 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 exclamation point, whatever. End quote, end parentheses. Now I'm going to go add a few more comments. Above that X equals 1, this comment's going to say loop. And then I'm going to add a comment out here saying, did I say parentheses? Pound sign loop. And then out here, pound sign output. And then over here, print, or pound sign increment X. Increment's a fancy word meaning store, add 1 to it and store it back into itself. And so what's that statement above it? Well, that really is the loop. So I guess I should have put my loop comment here, which I'm going to do. After that while statement, I'm going to put the loop comment here. This could also say update X. right? Because it didn't have to be going by 1. We could have been adding 10 to it each time. If we wanted to count 10, 20, 30, 40, 50, we could be adding 10 to it each time. All right, I'm going to save it now. So I hit Control S, or if you like doing File, Save, great. I'm going to save this into my CIT1113 directory. You can save it anywhere you want as long as it's not in this Python 3632 directory. It'll let you, and then it'll break Python later if you keep doing that. All right, so I'm just going to call this Lecture B. Lecture B. And if I felt like adding the .py, great, but it assumes that if not. Now I'm going to run it and hope I don't have any syntax errors. Run module. You could check the syntax of it by just doing check module. Maybe it'll find it. But if it does a blank screen, it didn't find any errors. Whenever you see this thing that says .shell, you can close it after it runs. You don't want to close your program though. So I'm going to close my shell because I just ran it. All right, now I'm going to actually run it. Run module. Or if you like keyboard, F5. How old are you? I'm 10. So it's going to print happy birthday 10 times. Heck, I'm 5 because I want to be able to count it easily. And it printed out happy birthday 5 times. Because X started at 1, it prints it, and then it adds 1, and then it checks again. And it keeps doing it until X is no longer less than 5. So 1, 2, 3, 4, 5. Now that for loop I said started at 0. I started this at 1, just because. Alrighty, anybody have any syntax errors that y'all would like resolved? I'm going to make a Dropbox for this so that the people who have the program running can upload this, and then I'll wander around and see if anybody needs help.